charge on each of the three capacitors nearest AB when the potential between A and B is 420 volts. So the charge on each of these three guys. What I'm going to do is start working backwards. So my last step of the previous problem, I'm going to redraw that. So there's point A. Here's the final equivalent capacitance. Point B. The potential between these 2 points is 420 volts. The capacitance we found right here is equal to 2.3 microfarads. So what we can do is figure out what's the charge on this. We know that capacitance C is equal to Q divided by V. So charge Q is capacitance times the potential. The capacitance of this equivalent is 2.3 microfarads. The potential is 420 volts. So we get a net charge on this equivalent capacitance of 9.66 times 10 to the minus 4 coulombs. So let's think, we know this is an equivalent capacitor. We found that in the previous part. Where did this guy come from? So let's back up a step. So this guy came from doing an equivalent of C1 here, some sort of equivalent here, and C1 here. So these are points A and B. This has the potential of 420 volts. This is capacitor C1. This is an equivalent. We found this in the previous step. So when we backed up, this had a capacitance of 6.9 microfarads. And this was C1. So what we know is that these are a series combination that came from here. So the charge that flows through here is the charge that exists on all of these capacitors. So for this guy, Q equals 9.66 times 10 to the minus 4 coulombs. We'll put in brackets, that's because it's a series connection with above. Likewise for down here, Q equals 9.66 times 10 to the minus 4 coulombs. And on this equivalent capacitor, remember this equivalent is not exactly what we wanted to find. We've got this guy is an equivalent that corresponds to all these. So this is an equivalent capacitor from all of these things. We only want the charge on this one, so we have to draw that meaning out of this one. So we know the charge on this one, we know the charge on this one, we have that part finished. We want to find the charge on this one, so let's see what we can sort out about this one. So on this equivalent capacitance, there is a charge of 9.66 times 10 to the minus 4 coulombs. What could we find out? We could find the potential on that guy. So since C is Q divided by V, then the potential across this equivalent capacitance right here is the charge on it divided by the capacitance. When we divide those guys out, we get 140 volts. So the potential across this equivalent capacitance is 140 volts. Now let's remember what this guy was. Let's back up another step. So far in our backup steps, we thought about this one and we found our capacitance here and our charge. Then we backed up to here and we found some charges across these two guys. We found the equivalent capacitance here was 6.9. We found the charge on this was the same as these guys because they're a series connection. We use the charge and the capacitance to find the potential. Let's back up one more step. This one is a parallel equivalent of these two. Since they're a parallel equivalent, these two are going to have the same potential, and this is the capacitor we're interested in. So let's back up to this step, write down what we know, and see what we can figure out. in our step we're backing up from, this equivalent resistance was 2.3 microfarads. We can write that down again, just to help us stay clear. This one is C2, so that's the C2 from the original diagram. So the C2 that we're trying to find here is the same as this C2, so we'll label that guy in. Okay, let's write down what we know. We just found the potential across this one. This is a parallel combination of these two guys. So this one, and this one, they're all 140 volts. Let's write down that potential. So if we know the potential and we know C2, we can find the charge. So Q equals C times V. C2 was given, that's 4.6 microfarads. The potential is 140 volts. So we multiply 4.6 times 140, we get 3.22 times 10 to the minus 4 coulombs. Okay, so there's our charge and our charge across each of those three capacitors. The last thing we're asked to find is the potential across these 2 points. So we'll do that part next.